Welcome to this edition of the Star Drive Report. Recently, I was invited to join what I consider to be one of the most interesting and worthwhile groups on Facebook, the Advanced Aerial Threat Identification Program, or ATIP group. In the course of monitoring discussions on the group, I came across a post by Dr. Kevin Knuth. After an exchange of replies, Kevin graciously sent me his slideshow that he was going to use in his upcoming presentation at the Anomalous Aerospace Phenomena Conference, or AAPC, hosted by the Scientific Coalition for Ufology, or SCU, held near the Redstone Arsenal at Huntsville, Alabama. Kevin's talk was titled, Constraints on Societies Engaged in Relativistic Interstellar Travel. I was mesmerized by his slide presentation. Kevin tied a number of questions together I've had about interstellar travel since I was a teenager. He presented an if-then scenario of how travelers from a society that developed the means to travel at extreme relativistic velocity would function. The closer one travels to the speed of light, the further one travels into the future of the planet they departed from. In other words, interstellar travel is essentially one-way travel. You can't go back home. And if these interstellar travelers are flesh and blood biological emotional beings like ourselves, then this is a hugely significant issue. Dr. Kevin Knuth is an associate professor in the Department of Physics at the University of Albany, SUNY, and is the editor-in-chief of the journal Entropy. He is a former NASA research scientist, having worked for 4 years at NASA Ames Research Center in the Intelligent Systems Division, designing artificial intelligence algorithms for astrophysical data analysis. He has over 20 years of experience in applying Bayesian and maximum entropy methods to the design of machine learning algorithms for data analysis applied to the physical sciences. His current research interests include the foundations of physics, quantum information, inference and inquiry, autonomous robotics, and the search for and characterization of extrasolar planets. He has published over 90 peer-reviewed publications and has been invited to give over 80 presentations in 14 countries. I'd like to welcome our guest, Dr. Kevin Knuth, to the Star Drive Report. How are you doing, Kevin?
Very good. Thank you for having me.
Oh, it's great. I mean, you recently did a presentation at the Anomalous Aerospace Phenomena Conference hosted by the Scientific Coalition for Ufology in Huntsville. And your talk was titled Constraints on Breakaway Societies Engaged in Relativistic Interstellar Travel. That's a really loaded title for a scientific conference, and it really blew me away when you sent me the slide presentation. And I need to ask, how did a mainstream academic physics professor like yourself become interested in the subject of anomalous aerospace phenomena in the first place?
Well, I've always been interested in astronomy and in the ideas of interstellar travel, so this is something that's always captured my imagination and my attention. That's and I've thought a great deal about this, during my career, so that's really where a lot of this talk came from.
And I went through the slide presentation very thoroughly, and I noticed that one of the linchpins of your presentation was the Nimitz UFO, or unidentified aerial phenomena, event a few years ago. And a lot of the things that you were talking about in your presentation involved the incredible behavior exhibited by these objects over the Nimitz group.
Yeah, certainly. Well, I mean, this is what scientists ought to do. They ought to study things. So I, decided to look at some of the accounts a little more closely and estimate the flight behavior of some of these craft. And one of the easy things to estimate is the minimum acceleration. So, say you have a craft that takes off and flies to a certain point and stops, you can estimate the minimum acceleration by assuming that it accelerates halfway and then decelerates halfway with a constant acceleration in both halves. And so I basically did this, for some of these craft, and found that these accelerations were pretty remarkable, ranging from hundreds of g's, hundreds of times the acceleration of gravity to literally thousands of times the acceleration of gravity in some cases, which is pretty inconceivable. So either something's very wrong here or something's very spectacular here, and so it's an interesting situation.
I mean, are you of the opinion that what was observed over the Nimitz group was real physical phenomena? I know there's been a lot of talk on the net and on the Facebook group, the Advanced Aerial Threat Identification group, which is a great group, by the way. Excuse me, I'm having an allergy attack here today. It's the pollen is
me too.
insane. It's just insane. Everybody's complaining about it. So if I clear my throat, please excuse me. But is there any doubt in your mind that what was observed over the Nimitz battle group was real?
It certainly, my impression is that they experienced something real. I mean, you've got claims that there exists radar data, that these things were tracked on radar. You've got infrared imagery that has been retrieved and made public. You have the objects that were sighted and by multiple pilots. So it certainly sounds like this is something real. It would be helpful if what's frustrating about all of this is that so much of the information remains classified and isn't disclosed. So you really can only go on the accounts reported by those who have come forward and are willing to discuss what they observed. And that's very difficult. If we were to have radar data, that would be much more interesting, or
Right.
higher quality visual images rather than infrared. Infrared is often very fuzzy, so it's not clear what you're looking at, and that's problematic as well. So I can see why some people looking at one or two aspects of this problem or of this situation might look at this and say, well, I'm very skeptical. But when you consider that you have people who are coming forward who said that they were tracking these things on radar, they basically can tell the whole story, how this whole thing progressed. You have multiple pilots who've come forward and talked about that they what it looked like visually and how the objects behaved. And you do have the infrared imagery. So it certainly looks like there's something here to study, and certainly if it is real, it certainly is worth studying. It would be foolish not to study it. So that's my take on it.
Absolutely. Was that the primary motivation for you to write this paper, or were you thinking about this before these events happened over the Nimitz?
Well, I had been once I had learned about the Nimitz encounter, I realized that you should be able to estimate some of these accelerations, and it was something I was basically doing on my own out of curiosity. And I went back and found a few other cases where you had eyewitness reports that had sufficient information so that you could come up with estimates of a minimal acceleration at least. One was the Graham Bethune's encounter over the North Atlantic in 1951, I believe it was.
Mm-hmm.
And in another was the Japanese airliner over Anchorage, Alaska in the 1980s. That case also, you had enough information from, well, there exists radar data as well. So you could estimate accelerations in those cases as well. And so I was basically doing that just to see what, how spectacular these objects are. Witnesses will report that these things were impossibly fast, and I decided to figure out, well, how impossibly fast. and so calculating or estimating these accelerations is interesting because you easily get numbers that are pretty fantastical, and most living things wouldn't be able to endure an acceleration over 25G. Most equipment wouldn't be able to endure that either. I think I was, like the F-35 fighter starts breaking apart around 13G. You're going to have wings ripped off and things like this, and it would be very bad. So these accelerations are pretty spectacular. regardless of whether they're piloted objects or not.
Right. Just from a materials and structural, structural physics point of view of materials that we're aware of, we don't have things like that.
Yeah, I mean, it's possible we could make something like that. I don't know how you would accelerate to anything at that rate. That's pretty amazing. The amount of energy is needed. You can estimate the amount of power if you make some guesses as to how much the thing weighs. So, one of the other talks at the SCU meeting was by Robert Powell and Peter Reale, and they did similar calculations to mine. They actually went into a lot more depth, and just estimating that the craft that was observed in the Nimitz case weighed weighed a ton, which is probably an underestimate. You would have to the amount of power required to accelerate a craft like this at the rates that were observed would be on the order of 9 gigawatts of power, which is really insane.
Yeah.
So,
I mean, how would you put 9 gigawatts in a platform that small?
well, yeah. If you think about it, the total nuclear output of the United States nuclear power plants comes out to something like 90 gigawatts.
Mhm.
So this is basically 1/10 of the total U.S. nuclear power capability, that's pretty ridiculous. So something, either these observations are way off and horrible mistakes were made, which should be of some concern,
Absolutely.
especially to the military. Either you have that situation, or if the observations are correct and you're actually observing craft doing this, then these things are certainly objects that you're going to want to pay attention to.
Mm-hmm. Well, I'd like to, if you could, give us a summary. You don't have to go through the actual presentation of your paper. I just want the audience to hear what you presented, because I think it's extremely important, given the fact that we are seemingly observing objects displaying these types of incredible behaviors. And you just took it from there. You presented kind of an if these things are real, then you took it from there. And how are they getting around? And they can, obviously, if they can display those types of accelerations, they can go a long distance in a relatively short amount of subjective ship time.
Right. That was one of the questions I asked myself. I often have people, if I'm talking to friends or colleagues about this, and I often have them pose the question, and it's a perfectly valid question. Why do people so quickly assume that these are extraterrestrial spacecraft? And now that I've estimated some of these accelerations, it's easy to see why you would assume that, because these accelerations are what you would expect an interstellar spacecraft to be able to achieve. How far could you get, with some of these accelerations? Well, if you were accelerating at a rate of 100 g of acceleration, of course, I don't know how you would do this, and I don't know how you would survive it. But some of these craft were observed to exhibit accelerations much greater than that. But if you even went for the lower limit of about 100 g of acceleration, you could traverse the galaxy literally from here to the other side of the galaxy in less than 4 months. So that in my mind is pretty spectacular. What about going to a nearby star system? Well, you could get to accelerate at 100 g. You could get to Alpha Centauri in about 45 days. That's ship time. You're going to be very quickly achieving relativistic speed, so you're going to be going close to the speed of light for a good part of that trip. And what that means is that for the travelers inside the spacecraft, traveling at those speeds, time's going to be going much slower than it is for us back here on Earth, or anyone.
This is very important for the audience. I didn't mean to interrupt, but this is a very important point for the audience to understand, the whole idea of time dilation.
Right. So in relativity, you have to go back to relativity and think about this. You can see this trip from two different perspectives. So from this perspective of the those of us sitting around in the galaxy, sitting on Earth, watching a spacecraft travel from here to Alpha Centauri at very high speeds. If we look at the clocks or how time is passing on the spacecraft relative to us, we're going to see that their time is moving very slowly. So time is advancing slowly for the astronauts. The astronauts, on the other hand, are going to see something different. From their perspective, time is advancing normally, and they're going to observe what's called a length contraction. So the distance between their spacecraft and the star they're traveling to, Alpha Centauri in this case, would be greatly shortened. So what that means is they have to travel at much shorter distance. So from our perspective, the astronauts can easily traverse these distances because they're going so fast that their clocks slow down. So they're basically, it's kind of like a poor man's version of hypersleep, where you put everybody to sleep and you make their clock stop, right? But in this case, everybody's awake and functioning normally, and the clocks are just have slowed down greatly. For the astronauts in the spacecraft, the trip is very easy to make because they're traveling so fast that the distances shrink. The distances are shortened, so they don't have as far to travel. So both of these perspectives are valid, and they both result in the same events occurring. So they're entirely consistent with one another. Now, what's problematic about this, and this is why what's problematic about this is if these travelers travel off to Alpha Centauri is 4 light years away. So even though they can make the trip in little more than a month, according to their time, for us, it's going to take about 4 years for them to get there. And then they're going to explore, will do whatever they want to do on Alpha Centauri, and then they come back to Earth, and it's going to take another 4 years for us. So for us, 8 years will have passed. But for the travelers, it will have only been 2.5 months or something on this order. So that doesn't make for exciting science fiction, which is why in science fiction films we have these ideas of hyperspace and faster than light travel. You want to have your heroes fly to another star system, battle Darth Vader or the Borg or somebody, and then be able to come back home in time for dinner. That makes for a more exciting story than for them to travel off and have it take years for them to come back. That's much less exciting. Now the problem is, and most physicists who've really thought about this realize that if you can get going fast enough, yes, you could easily traverse the galaxy in a pretty reasonable period of time. If you were to accelerate at a comfortable 1g of acceleration, so you basically are accelerating the craft at the acceleration of gravity. So there you'd have an artificial gravity, which would be nice and comfortable. But you then would, take a little longer to reach, get close to the speed of light. But you can still traverse the galaxy, and it would take you 20 years instead of, whatever, a few months, depending on whatever accelerations you're using. So so while scientists realize that that's possible, the general response is, but what society would bother? Because if we want to send, a probe to, say, the Orion Nebula, or send a spacecraft to the Orion Nebula to explore it, it's basically, the Orion Nebula is around 1,400 light years away. So it's going to take the probe, for us on Earth, it'll take the probe 1,400 years to get there. And it goes and collects whatever data and then decides to fly back, and takes another 1,400 years to get back. So for us here sitting around on Earth, the spacecraft will have taken about 2,800 years travel time. So it's almost 3,000 years later. You're going to have to wait until you get that information.
Right.
And and so most scientists have just thrown up their arms and said, well, who would bother? Why, relativity would work in your favor if you could get going this fast, but what's the point? We all don't want to all sit around for that information. And so I had thought a good bit about this, and I thought, well, I guess I'm inspired by the fact that there are some people who would want to do this. I would really like to travel to another star system. I would find that very exciting, and I would consider such a trip. But But then I thought, well, somebody's going to want to do this. So how can you make this work? And I thought, well, it's really not a big deal. This time problem isn't a big deal if you travel with a bunch of friends. So you can do it a few different ways. You could have a caravan, so you and your buddies fly off and explore a star system and come back.
Interstellar gypsies.
Yeah, or nomads. You basically could become nomadic. So you basically have a society, a sub-society of people who are travelers, and that's what they do. They travel and they explore the galaxy. And you could actually, so I started modeling this. Would this actually work? Could you do this? Would they be able to meet up in the future? And and how would this sort of work? So there are some interesting details that I go into the talk a bit and discuss about in the talk. But the gist is, I've now run some simulations, and one of the simulations I've had explorers travel out. I think about a total distance of travel time being something like 2,000 years into the future. And they then come back and meet up, and basically for some of them it's been a 6-month trip, and for others it's been a 2-year trip. But so there's a bit of dispersion in travel times depending on where they go and how fast they're accelerating when. But basically you could actually travel those distances and arrange meetup times, and do it in a reasonable fashion.
That's the part that I really found fascinating, because if, we had Stephen Hawking remarked on a number of occasions that the only real future for this planet is for us to get off of it and get into interstellar space, because of any number of disastrous scenarios that could befall our planet in the near and not so near future. And the whole thing, it all revolves around the idea of biological beings, emotional biological beings like ourselves, doing this. Now it's obviously a different scenario if these are artificially intelligent machines, like von Neumann probes, doing all this.
Yeah, it's potentially different. I mean, it depends how patient they would have to want to be. And, if they all came back to a source, and there's some of them were hanging out on, on their home world or wherever their area, place of origin would be. But again, if they were all nomadic, they could easily just meet up and trade information whenever they met up, and that would be a much easier solution, actually. So if you're going, the point is, when taking advantage of relativity like this, what that means is that traveling through space is equivalent to traveling through time. So when you're traveling through interstellar space at relativistic speeds, you're basically traveling into the future. And you could have the whole society basically where everybody is just continually traveling. As long as somebody does a good bit of the right amount of traveling, everybody in the society can travel into the future together. But when and after I thought about this and did some modeling, I thought, well, what's such a society be like? We often imagine that there are going to be cultural differences, but this is a big cultural difference. This is going to induce some very striking differences. And so, for one example, one thing is that if you were to encounter a planet with life on it, and this life basically resides on the planet, there's really no point in making friends, because the next time you come back, it's going to be hundreds of years into their future, maybe thousands, depending on how far you're traveling.
Right.
So people, often when talking about UFOs, they often joke, well, why don't they land on the White House lawn? Well, I often have several impressions. Why would you choose the White House lawn to represent Earth and not some other place? And then my second thought is, and now that I understand this, about relativistic travelers, why bother to land on the White House lawn? Because the next time you come back, there probably won't be in America. It's really that dramatic. And so, the one simulation I did, I ran it for 2,000 years on purpose. And so, and for the travelers, that 2,000 years passed in just anywhere from 6 months to 2 years for them. And so the other interesting thing is that you, as a traveler, you would be able to watch societies grow and evolve. So if you were studying a society or a civilization on a planet, you could actually watch it change through thousands of years of evolution. So, in that example that I showed, I had a little video I showed at the conference. In that example, where the travelers traveled 2,000 years into the future, when the travelers first encountered a planet, if they imagine they had come to Earth, they could have come to Earth 2,000 years ago during the Roman era, and 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 then come back to Earth by the end of the simulation. You could come back to Earth by the end of the simulation, and that would be the current modern era, and it would actually. What's surprising is those could be the same travelers. They could be the same spacecraft.
Wow.
So I had read, there's the book, I think is by Jacques Vallée, about Wonders in the Sky, where they talk about old UFO sightings, and there was one count, I think it was in Tarquina, during a Roman battle, where 3 Orbis Clypeus flying shields flew over the battlefield, and it occurred to me, I thought, wow, those three craft, if they were actually interstellar spacecraft of this type, those 3 craft could have been the same craft that were seen, by Kenneth Arnold in
Right,
1947. They could be the same craft piloted by the same individuals.
Or the same craft that were flying over the Nimitz battle group, for that matter.
Yeah, exactly. So the situation, if you're dealing with interstellar relativistic travelers, the situation you're dealing with is far stranger than what we would have first expected. And I found that to be really surprising, when I considered that.
Yeah, I think a lot of do you think a lot of the prejudice against in mainstream academia against human interstellar travel is revolves around this whole idea of biological beings like ourselves, emotional biological beings? It's just so alien for us to leave our planet forever, leave our families and friends, and do this. I don't know. Are we emotionally, psychologically, physically even capable of such a thing, do you think?
Some people are. Some people did that when they came to the New World. When they left Europe and came to the New World, there was no going back,
Absolutely.
for many of them. And they knew that. So they were leaving relatives forever, basically. I think the biggest hang up is the engineering. We're new at spaceflight, and it's not obvious how you could design a spacecraft to achieve those speeds. The amount of energies it would take is enormous, and there are all sorts of horrible, and I mean really horrible, engineering challenges that you'd have to overcome to be able to pull something like that off. And I think that's really where the hang up is. The fact is, though, that there are those of us who are trying to accomplish this. One of NASA's goals is to get a probe to Alpha Centauri by the 100-year anniversary of the moon landings.
Mm-hmm.
So the idea is to get a probe to the nearest star 4 light years away by 2069, which is now 50 years away. So we've got 50 years where we basically have a plan to get a probe to the nearest star in 50 years. So we have people working on this. There are good people working on this, and some of these engineering challenges may be overcome, which would be very exciting.
I remember reading a few years ago, it was probably almost 10 years ago, amazingly. It was Mark Millis's project, the NASA Breakthrough Propulsion Project, and reading a lot of the data that they came out with, and using the standard rocket equation, I mean, it's just like when you get into that extreme. Let me go to your slide presentation here. The region of what you call the region of extraordinary propulsion, where you're getting up into, a little less than 1/10 the speed of light up to, you know, close to the speed of light. You'll never reach the speed of light if you're a massive object, but
Right.
the amount of energy required is just ridiculous. I mean, it's absurd.
That's true. Yes, that's a big problem. And so it's not clear how achievable this is. And maybe we can't get up to 80% the speed of light. Maybe we'll have to settle for 20%. But, um,
Well, that's according
and
to our current knowledge of physics. And I mean, is it possible that we don't know all the physics that we think we do, and that there could be some black swans or, real surprises around the corner here that would
I
allow
would,
us to create warp drives or wormholes?
I would defer to Werner von Braun, who said that he had learned to use the word impossible with the greatest care. And I think that's really the wise approach. The point is that, there we're still learning about physics, we're still learning about material science, we're still making progress in a lot of areas. Whether there's that much more interesting physics that we could learn that could be useful to this, I don't know. But then the other point is that, and engineering is not physics. Engineering is coming up with workarounds and coming up with ways to do things differently, and that's where a lot of the advances are going to happen, and those are really unpredictable. And physicists who've attempted to make predictions about engineering, I don't know. I don't want to fall into that class of people. So, one of my favorite quotes is from Lord Kelvin in the late 1800s, where he said that heavier than air flying machines are impossible. So, there you go. And the astronomer Royale, 2 weeks before Sputnik launched, said that space travel is bunk. And so these are difficult. Making advances is a difficult business, and that's why they're called breakthroughs. Nobody saw them coming. So it may we would need several breakthroughs to be able to pull something like this off, and whether those breakthroughs are possible or not is anyone's guess.
Hmm.
But my way of looking at it is that they don't happen. The sure way to have them not happen is to not try. So
Exactly.
so you need people to be trying, and that's what's necessary.
Have you, as an academic, have you noticed that more and more serious mainstream academics are entertaining this possibility and entertaining this subject, period, than before? That the interest in this is increasing, and that people are being less inclined to hold their cards close to the vest and get out and extrapolate like you did. I mean,
I, th- I think
I'm
that I
noticing
think
it.
that people are probably more willing to consider the possibilities of interstellar travel. I'm sure that's the case. And that's for a good number of reasons. We've had a great amount of success in the last 50 years with our space program. We basically explored our entire solar system with robotic probes in the last 50 years, so that's a big deal. And the scientists today grew up with that, and they grew up with that happening. And so, the next step is to reach out to the stars, and that's what a good number of us would like to do and would like to think about it. And with space being commercialized now you have many more people active in trying to do interesting things, and I think that's going to lead to a larger number of breakthroughs and more rapid advancement.
Hmm. I'm
I
curious.
think.
Go ahead.
Oh, I was just going to say one of the other thing is that I think science fiction has also played a role in shaping how we view things. Science and science fiction kind of work together in an interesting synergy where scientists are inspired by science fiction and then work to make it happen. And then science fiction takes those advances and extrapolates on them, and that cycle seems to continue. So, Robert Goddard decided to um, study and develop liquid fuel rockets because he had read War of the Worlds and was interested in seeing if he could send a rocket to Mars. And that's how he got involved in this. And if it wasn't for his advances, we wouldn't have gone to the moon when we did. So I think that a lot of scientists today, we've grown up with science fiction where interstellar travel is a large component of that fiction, and I think that a lot of us would be interested in that.
Did you get any heat from your colleagues for doing this presentation?
No, not at all. Actually, my colleagues have been very supportive. I basically am in this presentation. There's nothing unreasonable here. You're basically
Mm-hmm.
looking at how and how a civilization of interstellar travelers would actually work and how it wouldn't work, and I'm basically studying that and modeling it. So I don't see any problem with that. I'm not claiming that anyone does this, and I'm not claiming that it's doable. and
Right.
but but if it were doable, this is what it would have to look like. It would have to be something like this because it doesn't work other ways.
Well, do you have any idea why the military would be so reluctant to release radar data from a contact like that?
I don't know. That's really would be
I
speculation on
understand. I
my part.
understand. I just
Yeah.
thought I'd throw it out there.
Yeah, there are a lot of possibilities, and it depends. In that answer depends on context, which is made up of other information that they know and also haven't released. So we don't know what that context is either, and so it's very hard to speculate why that hasn't been released.
Yeah. Well, it was
I
a
wish,
military
I wish
operation.
they would. It wouldn't. Yeah, I wish they would. Would be very useful, to be able to see what those craft were doing,
Absolutely.
while traveling. Were they traveling? The accelerations I estimated were, assuming that they were accelerating at a constant rate halfway and then decelerating the other half, which, it's likely they weren't, which means that at some points they were probably accelerating even faster than that.
I mean, you would think that any kind of a biological entity aboard something that was accelerating at that enormous velocity would be destroyed. So, are they? Is this a warp drive? I mean, wouldn't that classify as a warp drive? I mean, maybe
Well,
they're
I
free
think
floating inside the craft and they're not really feeling any kind of acceleration. They're just floating along the geodesic in free
Yeah, well,
fall.
that's one possibility. The problem is that we don't have a lot of ideas on how to do this because we haven't really thought about engineering something like this before. And so it's hard for us to imagine the different ways you could do this. And, some of us after the meeting have been kind of brainstorming back and forth by email. Could you do this? Could you do that? And, how does that match with the data? How does that, the data being what was observed, which is not that much that we know of is at this point. So there's not much to work on, not much information to go on, but you know, it's coming up with basic ideas with the physics on how you could pull something like that off is an interesting problem.
Where do you think this is going from here?
I have no idea. I
I mean, I'm at a
think
loss for
that
words. I'm going through your slide presentation, and it's like you've already answered most of my questions, but I'm just curious where we're going to go from here.
I
Bec-
think that if these are real craft and we continue to encounter them, then the scientific community is going to slowly take notice. It's going to take time.
Right.
There's a huge stigma against this idea,
Hmm.
and and that's going to take some time to overcome, and it's going to take hard data to do it. It's going to take something like radar data to convince scientists that this is worth looking at. Now, what's what probably will happen is that once you have a few scientists who are actually looking at it, and once they are able to obtain data themselves, then other scientists are going to see this as potentially profitable, and you'll have a number of people moving over to study this, which is what ought to be happening anyway.
I mean, do you see that happening now? Do you get any inklings of that happening?
Oh, I think it's happening. I wrote a paper. I basically um, dove into this fray last year when I was invited to write a paper for the online journal, The Conversation. And so I wrote a paper that scientists ought to be studying UFOs. And I was, of course, I carefully crafted that paper and was worried about the possible, backlash and negative commentary. But that isn't what I got. I was pretty surprised to find that, I got a good number of emails from scientists who basically said, "Bravos, we do need to study this, and I'm glad that you had the courage to say that." And so the responses went from that point all the way up to, that was a great paper. I'm glad you're interested in studying this. I've been studying it in secret, and I've been looking at this aspect of it, or I have some data on this. And I had a number of people basically saying, I want to study this. I've been trying to, but don't know how. And so there have been a number of scientists who actually want to study this phenomena. And I think that to me was very exciting, and made me think that, this is where we're going to start to learn something. So.
So the dam is about to break, possibly. It's leaking at this point, and
Yeah, it's leaking. Yeah, people are interested. I think that the big difference is the mindset. And if you go back, let's go back to Kenneth Arnold in 1947 and Roswell and all that. That all happened in 1947, which is where basically the idea of UFOs entered our cultural consciousness, and this became part of our cultural story, right? I mean, what was going on in 1947? Well, you're just out of World War II. You've got, it's 10 years before Sputnik. So you're 10 years before we've launched a rocket into space. Anybody's launched a rocket into space. So it's not even clear to a lot of scientists that that's even possible yet. So the idea of space travel is not on anyone's mind. It's on, a handful of people who are working on it. But outside of that, many scientists believed that it was not possible. And like I had mentioned earlier, the astronomer royal in Britain had said 2 weeks before Sputnik that space travel was bunk. So the mindset in 1947 is it's not clear space travel is possible. We had some idea of what the planets in our solar system were like, but not we didn't know what we know what the atmospheres were like. So, but we knew they weren't like Earth, but we didn't know what the surfaces were like. We didn't know if there was life on Mars or not. It was not obvious. We still don't actually, which is interesting. And then in 1947, we didn't know if any other stars had planets. That wasn't even known. We didn't discover the first planets until the 1990s around other stars. So here you are in 1947. We have these craft that are observed that some people are hypothesizing are alien spacecraft from another planet or another star system. We're not even sure space travel is possible at this point. We don't even know that there's any planets to go to. And so what are people going to think about this hypothesis? Well, it's pretty ridiculous, right? It's pretty
yes, it
far
is.
out.
Well,
But
what
now
if?
fast forward to present time. Fast forward to present time. Now we know we've explored our solar system with our own probes. We know you can send probes to other planets because we've done it. we've sent people to the moon. We now know that there are thousands of planets orbiting other stars, and we're continuing to discover more, and we're constantly, and at this point, we're producing missions left and right to study planets orbiting other stars. So now the mindset's totally changed. We are, we have some experience in being spacefaring. We're going to be sending people back to the moon, within the next 10, 20 years, something like that, and quite possibly to Mars. So there are, SpaceX is talking, Elon Musk is talking about colonizing Mars. So space travel possible? Well, of course it is. For us, this is a no-brainer. This is a natural way of thinking. And so now the hypothesis that you could have travelers coming here from another planet isn't so outlandish. Yeah, it would take some huge technological advances, but it's not outside the realm of possibility.
Do you see in the future serious academic studies being conducted in this anomalous aerial phenomena without a professor losing their funding or being ostracized?
No, I mean possibly. I mean, look, if these were real craft, they ought to be studied. There's no doubt about it. If you have anomalous craft with, these very advanced, flight characteristics, coming to Earth, we all ought to know where they're coming from. We all ought to want to know why they're here.
Right.
I want to be political, but right now Americans are worried about Mexicans. Let's put this in perspective.
Yeah.
So if you've got somebody else coming here from another solar system, you're going to want to know about it. And I think that's important. Now, it's not clear that that's what these things are. It's not clear that these are really craft. It's not clear that they're piloted. It's not clear, none of this has been proven yet. And in fact, the problem of proving that something is extraterrestrial is not easy to imagine. Even if I was holding material in my hand, I'm not sure how I would prove that it's extraterrestrial.
Right.
One of the ideas is to look at isotope ratios, but we can manipulate isotope ratios. So it's not obvious, even if you have, hull material from one of these craft, it's not obvious how you would prove that it's extraterrestrial.
Mm-hmm.
That's proving it scientifically is going to be a difficult problem. You'd have to capture one of these and pull an alien out of it to convince anybody.
Well, the military national security establishment, would you not agree, could be in possession of a lot of facts that we are not in possession of, and be holding those facts back for what they believe to be worthwhile national security purposes, which would be one of the reasons why they didn't release the radar information. I mean, that might be one of their motivations or rationales for not releasing that information, because...
Well, we're told by people who ran the ATIP program that there is information that they haven't released. So I don't know precisely what that information is and what it shows, and I don't know. There's also some indications that there have been other programs, so it's not clear what other programs, what information they've collected, and it's not clear that those programs communicate with each other either. So there's just a lot that's not known at this point, and for scientists to get involved, that requires scientists to study this openly and to share data and all of that, and that's going to take. The military studies aren't going to produce what scientists need to be able to really understand these things.
Well, if more people like yourself, more scientists like yourself, do this kind of research, and there's some kind of a consensus or near consensus is reached in the future, wouldn't you think that would be a motivation for those who are in possession of information that the rest of us are not, to sort of release that information in order just to further our knowledge?
It depends on what their motives are for keeping it classified. So
Yeah,
I
yeah,
couldn't speak to that.
yeah. Wow. So where are you going from here? I mean, are you going to be doing more of this type of research, or?
Well, it's hard. I don't. It's researching a phenomenon that you can't control is a difficult thing to do, which is why it's gone unstudied. And that's one reason why earthquakes are hard to study. You have to sit and wait for them to happen, which is it's why earthquake lights weren't understood until very recently. Um, and so this is another an example of a phenomenon that's difficult to control, and it's really a matter of sit and wait until you can collect some data. So the question really is, how do you collect data on something that you can't control? How do you either go to where they are, which that's not obvious what to do with that. So try to get them to come to you. You could try something like that. I don't know how you would do that either. I'm just brainstorming at this point, but these are things that you could try doing. Now there are some possibilities with satellites, which I think is interesting. So another talk at the meeting was by Philippe. Oh, I'm going to massacre his last name. I'm sorry, Hilaris, from the European Space Agency. He gave a talk on photographing these objects from space with satellites, and this is something I had also looked into. So I was very excited to hear his talk because if you have a large UFO sighting, that then it's very possible that you should be able to get satellite coverage of that area during that period of time.
Sure.
And some of these things, anything larger than 40 feet across is probably easily seen in satellite imagery. So these things ought to be able to, at this point, we ought to be able to easily confirm or deny the reality based on, in the cases of, observers or witness sightings.
Yeah, I always thought that nanosats would be an ideal vehicle with which to use, and launch a privately funded group of nanosats that are multispectral, capable of multispectral imaging, and just have them covering the planet and seeing what's entering and leaving our atmosphere.
Yeah, that's another thing you could do. Yeah, there are some options, and I'm trying to think of options that take advantage of technology that already exists. Try to do it cheaply. So if you have a UFO sighting, a large UFO sighting, especially if you've got multiple witnesses and photographs, you should be able to get satellite imagery of that area and see it by satellite. That would be interesting. And I've talked to a colleague about this, and of course, they were very skeptical. But my response is, what are you skeptical of, the hypothesis or being able to see them? Because as a scientist, my job is to collect data and examine the data. So then we can confirm or deny the hypothesis. That's when we do that. You deny the hypothesis after you don't see it in satellite data a lot, right? And so that's what we ought to be doing.
Well, I know that.
So that's one step, and that's something that could be done now, which I think is a possibility.
Yeah, well, we've got Mars. We've got Seth Shostak from the SETI project. He's pretty optimistic that we're going to discover alien life within 20 years. I think that's what he said, around 20 years. I'm just curious. I'd like to end our discussion on this question. If for some reason the dam does break and we, scientists get together and people like yourself come to the conclusion that some of these aerial phenomena that we're seeing is extremely advanced technology, even not knowing where it may be from, we can come to the conclusion that we are being visited either from somewhere or from some time by these types of craft, and it becomes mainstream that these are real. How do you think that's going to change society?
Oh, that's a big question. it'll have a profound impact on our society, and it's not clear to me. I don't study societies, so I'm probably not the best person to ask on what kinds of changes to expect. Um, but I think it'll probably have a profound impact on our society. And that impact will depend greatly on what's learned when, and how much is known, and what's actually found out. Are
Hmm.
these autonomous probes? That's going to have a very different impact on us than if they turns out they're piloted. And it also depend on how many craft you have visiting the planet at any point in time. You use the I thought it interesting that you use the term visited, which is what most people use. The fact is that if there are interstellar craft coming to Earth, they've not been studied, and thus no one really knows how many there are at any point in time. So the word visited might not be appropriate. It could be populated. It could be,
Yeah,
much.
really.
We don't we don't
You're
we
right.
don't know. We don't know what the situation is. It hasn't been studied, and that's one reason. That's another reason for studying it.
I mean, these
And maybe
nomads could be hanging out in our solar system, and we wouldn't know.
they could hang out in our solar system. They could hang out in our oceans. We wouldn't know it.
Right, right.
There's a lot of possibilities. A lot of the Russian military sightings. 2/3 of them are associated with water. So we don't have access to our oceans. And if they could hang out in our oceans, and be really nothing we could do about it, and we wouldn't even know about it.
Right.
So there are possibilities that exist. They are, admittedly, each one of these possibilities is pretty far out, but the fact is that it hasn't been studied, so it's really not known what the situation is, if any, if there is a situation.
Wow. Well, Kevin, this has been a fascinating conversation, and I really enjoyed it.
Oh,
And
thank you.
if anything comes up, if anything comes up in the future, please get in touch with me because I'd like to have you back on.
Oh, certainly. Well, thank you for having me. I've enjoyed myself as well.
All right. All right. You will have a great day, okay?
All right, thank you.
All right.
You too. All
Bye
right.
bye.
Bye-bye.